Welcome to the Databricks Skill Builder series. We're glad you're here.
Hello, everybody. My name is John Ward, and today I'm here to talk about our data intelligence platform and how we can help you democratize data and AI. So, at Databricks, we have a core philosophy that we believe that the winners in every industry will be companies that best utilize data and AI as a tactical advantage. Now, I've been in this industry for a long time, and for a long time, we've always had the belief that data was the biggest part of this, right? Because AI is something that's come about in the industry very recently. So, and we've always said that companies that could best leverage the tactical advantage of their data to achieve strategic objectives would be the ones that were most successful. Perfect example of this is a company like Amazon. If you look at Amazon, they were able to successfully leverage a lot of data that they were getting, especially customer data, to expand and increase their business to the point where they're at today. So they were able to do things like create customer recommendations, product recommendations. They could take a lot of this data that they were getting from their e-commerce business and optimize their supply chains and optimize their logistics. And they could take a lot of this data that people are creating and that they're utilizing to expand their businesses into areas like AWS and Amazon Prime. Well, with the increase of AI, we've now realized that AI and data are going to go hand in hand. So companies that can leverage the both of them will be very dominant and have a massive strategic advantage in their industries. A perfect example of this, and we'll take three of them, are companies that are leveraging the Databricks Data Intelligence Platform to achieve such advantage. An example like JetBlue, where they're taking their data and AI and they're creating digital twins of their flights so that they can do things like improve operations. They understand things like weather patterns as flights are happening and when maintenance needs to happen. A company like Intuit that's using their data and AI to simplify and improve their loan application process, and a company like AT&T where they're utilizing their data and AI to stop fraud. They've seen an 80% reduction in fraud in real time before it could happen. So this sounds great and all, but here's the problem. This is not a simple process. This is actually a very hard process. And the reason for this is a lot of this stuff is broken out into separate systems. If we look at just the data aspect of it, data is typically coming from a lot of different transaction systems. Oh, things like CRM systems and point of sale systems and HR systems. And to get around a lot of this, companies have, leveraged data warehousing, where we say, let's take all of these siloed data systems and put them into a single data warehouse. And then you had a separate BI stack that, analysts would say, all right, we want to run our BI and reporting off of this data warehouse, but it was separate and it could be in a system like Tableau or something like that. And then you would see the increase, over time of leveraging structured and or unstructured and semi-structured data inside of things like data lakes. So as cloud storage became more available, companies started to say, hey, let's take this unstructured data and store it in a data lake, but we want to make use of it. Data scientists want to be able to leverage this and create machine learning models. And so this was a whole other separate set of systems. Then we would see the increase in the demand for real-time data processing, streaming data, things like IoT, stuff coming from Kafka and CDC messages from databases. Now, the struggle that would come across this is with all these different disparate systems, how do you govern them? How do you control, how this is being utilized? How do you track where it's being consumed upstream and downstream for its lineage? How do you handle security? Each one of these systems has their own different security mechanism. And even worse is governance systems themselves become their own separate disparate systems, along with orchestrating the data flow, transforming it into something useful. And now we have generative AI, a whole other mechanism, a whole other system. These all are these separate siloed systems. So data and AI is very siloed, which makes it very, very complicated to work with. Now, we've heard a lot about this over the past year. What some of the challenges come around data privacy, like, oh, we want to make sure that private data, PII, things like that are not getting into the models and to the data that we're serving with these models. And finally, all of these disparate systems are dependent on highly technical staff to make them usable for individuals. Well, Databricks several years ago came up with the concept of the lakehouse. We invented the idea of the lakehouse. And the idea of the lakehouse is that it is an open, unified foundation for all of your data. What does that mean exactly? Well, we said, hey, let's take these open data storage systems, these cloud storage systems that companies like AWS and Google and Azure are putting out there, and let's put everything in there. Let's put our structured data, our unstructured data, and things like relational databases, logs, text. All of this will go into these storage systems. On top of that, let's build a unified data storage accessing system that will reliably and performantly access this data and make it usable. And let's create a unified approach for handling the very complicated topic of securing this data, tracking its lineage, knowing where it's coming from, where it's going, who has access to it, and even cataloging what's in these systems. And finally, we want to be able to build on top of this concept so that we can serve our data scientists, our data analysts, and our data engineers so that our data analysts can work with this stuff in a familiar data warehousing type environment. They can access this structured and unstructured data that way. We can orchestrate the entire data life cycle from the consumption to the usage of it and control this with things like ETL, real-time analytics, and finally serve our data scientists, allowing them to have full life cycle control of developing models, testing the models, serving the models, and fine-tuning those models. Now, we pioneered this and in 2000, and over 70% of organizations today have looked at this and said, yes, this is a great architecture. We like the Lakehouse architecture, so we're going to adapt this into our enterprise. This is great because it's built an open foundation that allows the Databricks Data Lakehouse to fit into the data and AI ecosystem. So instead of this proprietary vendor locked in system, we can work with data partners. Imagine being able to bring in things like your Salesforce data into Databricks. Imagine being able to bring in relational database systems, both on-prem and in the cloud, to work with data that is coming from something like Salesforce, orchestrating it with, things like infrastructure as code, like Terraform, and then connecting to other data sources, things like, document databases like MongoDB or something like Neo4j. If so also being able to do something like report off of it with your existing BI tools. Hey, I'm already a Tableau user, or I'm already a Click user, a Power BI user. I want to be able to report on this data inside of Databricks. So all of these other aspects of the data and AI ecosystem Databricks can work with because we have an open ecosystem, an open foundation. Now, we understand what the concept of the data lakehouse is and what our vision of it was, is to create this open unified foundation for your data. But with the increase and the use, increased use of generative AI, that's where we said, okay, how can we not only facilitate the creation of the models, but actually utilize generative AI inside of our platform and make use of this? And that's where we now have the data intelligence platform, the ability for us to, inside of our platform, democratize data and make it usable for the entire organization. So we take this concept of the data lakehouse and we say, hey, let's embed generative AI into it. And that's where Databricks IQ comes from. It is the core engine that will understand the semantics of your data. It understands what kind of data is in there, and it allows us to do some very powerful things, such as if we work with our Unity catalog inside of the Lakehouse, it'll say, great, now I can get insights into my data with natural language. I can type in something in plain English and know what kind of data is in there, how it's being secured. I can, make sure the quality is good on this. I can go into our Delta Lake and say, all right, based on standard usage patterns, let's optimize the layout of the data. It gets more intelligent the more the system is used. As a BI developer, this is something that's very, very key to me, is when we go to our data warehousing part of it and we say, hey, how does Databricks IQ work with this? Well, it lets me do things like text to SQL. I can use natural language to write queries. So I could do things like say, hey, give me these sales numbers for the second quarter across product lines in plain English, just as I had said it, and get my results back. I can work with my workflow layer, my orchestration layer, and it will say, let's go ahead and optimize for cost and performance. And we can determine this based on past runs. So it gets smarter. It knows how to run things better for cost optimization, performance optimization. We can look at our ETL with Delta Live tables, and it will start to automatically be able to determine when we're starting to see quality degradation. We can, take what we've already been doing with machine learning and AI, where we've had this full life cycle control. But with our recent acquisition of Mosaic AI, we can say, let's create from the ground up large language models. Let's go ahead and create, tune, and custom serve. So Mosaic AI lets us create custom models from the ground up, serve those models, and enhance them with retrieval augmented generation. So we can say, hey, not only can we create chatbots that customers can interact with, but we can make the answers context specific with organization data. And this enhances what we're already doing with our end-to-end AI workflow. So ML ops, controlling the entire life cycle of serving data to models, creating models around this data, um, experiment management. It also works with things like auto ML, which for me, this is great because this is truly democratizing the model creation process. I'm not a data scientist, but AutoML lets me create models off of my data, will create the experiments to determine what's the most optimal model. And then finally, I can go through once I have these models and monitor it and determine, hey, is this model degrading over time? And then govern it. And let's make sure that the data that's going into my models is data that is allowed to be shared. I can track where this data is coming from, where it's being used, making sure that I'm not serving, copyrighted material or PII inside of my models. So, with that, we have an idea, but how do we democratize this? How do we make this available for everyone in the organization? How do we make sure that finance and operations and marketing and customer service can utilize this data, can leverage this data? Because most of these folks are not developers and they want to get access to this data. Well, that's where we came up with the idea of Project Genie, the ability to go ahead and interact with this data just like you would a person and get actionable insights from the data with natural language. So we're going to see an exciting example of that and how we could utilize that. So with that said, the data intelligence platform here enables you to truly democratize data and AI by making it accessible with natural language so that everybody could use this. We make it simple to operate. So we remove the complexity and heavy lifting in all aspects of the data generation process. And we make a very strong security and governance model so that we can train and serve Gen AI applications that maintain your privacy so that we're not serving PII and we're not serving copyrighted material, that we're securing this and making sure that we're seeing exactly what we should be seeing in it. So with that, let's go ahead and jump into a demonstration. Let's take a look at what this is going to look like. So I'm going to come over to my Databricks environment. Now, in my Databricks environment, I would come over to catalog. I would select my catalog. In this case, I'm already inside of my IoT catalog where I'm keeping track of data coming from energy producing devices. And in this case, I want to be able, this is building machine learning models for predictive maintenance. I can predict when failures are going to happen. But let's say I'm a brand new developer and I'm getting thrown into this. I have no idea what any of these tables mean. I've never worked with this before. And this is a familiar scenario for me as somebody who is a former consultant. Let's see. We have one chat question. Does everyone's not see the workspace?
No, I'm just seeing your slides.
Okay, let me stop share and reshare real quick. Okay, I see. I see what happened. For some reason in this version, this mode in Zoom, it only shares windows. It doesn't share desktops. Interesting. Okay, so now do you see my workspace?
Yeah, we can.
Yes.
Okay. Sorry. I apologize for that. Okay, so here we are inside of a catalog, and we're looking at, in this case, it is an IoT use case where, as a new developer, I don't know what any of these tables mean. So let's say, as a previous consultant, this was a scenario I would run into very often, where it's like, hey, look at this database. Older databases may not have had very good naming conventions for tables or for columns. So it'd be like, what does any of this mean? Well, this is where our Databricks IQ technology comes into play. And looking at our data that's inside of this catalog, it can look at this and say, hey, this is the historical turbine status table. It records the status of individual turbines over time. This table can be used for analyzing trends in turbine performance over time, identifying recurring issues or anomalies, and understanding how to effectively different turbines are being managed on their rescue histories. It is giving me a description of what this table is doing, not just from data that it's storing, but also a potential business use case. That's something that's very powerful, especially if I'm coming in as a new developer, letting me know what this table is doing. Now I can go in and edit this and change the AI recommendation and accept it, and it becomes part of our catalog. It becomes part of the corpus of data that the AI is going to utilize. I can also say, great, generate a description of all of my columns. And when it does that, it will let me know what each one of these columns is doing. And again, I can come in and edit this. I can accept these recommendations. And once this is all, kind of set, I can come in and start searching for stuff using natural language. So, hey, give me, tables that have turbine parts. And in this case, it gives me a list of different tables across all my different catalogs. I can go to view all, and let's say I'm only interested in my catalogs. I don't want to see everybody else's catalogs. Hey, look, it finds my parts table for me. It finds turbines, which is also using parts. And I can say, okay, great, this is amazing. I can easily find stuff inside of my data using a natural language search. And it's aware of all of the history. It can tell me, okay, where is this being created? Where is this being used? In this case, parts is just being used in a couple places. So if I look at something, let's say, for example, with my bronze table, and I look at the lineage of that particular table, I can see exactly where data is coming from. It's coming from this data processing script. It's being streamed into the actual sensor table, and then it's being used downstream inside of this materialized view, and this table being used for training the machine learning models. So Databricks IQ is aware of all this. So when it generates the the description of the table and the columns, it can take that into context where it's being generated from and used in those descriptions. This becomes very powerful because there's a lot of cool things we can do. But how else is Databricks IQ helping to enhance and democratize my use of data? Well, if I want to go ahead and, let's say, create a brand new notebook as a developer, I can, come in and interact with my Databricks assistant, which is just like it's basically a chat bot that will assist me with developing my notebooks or my SQL queries. So I can come in and, for example, say, hey, write me a Python program that will generate the first 1,000 prime numbers. As a computer science grad from many, many years ago, we love our prime number generation programs. So I can go ahead, hit that, and it'll say, okay, certainly, here is a Python program that will do just that. All right, cool. So I could take this and say, go ahead and insert this inside of my notebook, and it gives me a program that generates the first 1,000 prime numbers. If I go ahead and execute this, I can see that it runs. But let's say I did something wrong and uh-oh, I fumble fingered something and all of a sudden there's a problem with my program. When I go to run my notebook, the data IQ can be used to diagnose the error. So it's like, uh-oh, there was an error. Help me diagnose this error. The assistant will go through and say, hey, wait a second, you're trying to print a variable that doesn't exist. To fix the code, change this from primes 1, 2, 3 to primes. Okay, I'll do just that and rerun this and have it go ahead and generate my numbers. So the data IQ engine and the assistant allows us to write code. But let's say we want to do something more specific to data. So I want to say, hey, write a program that will get data from a MongoDB database. I have a collection called customers and a database called my first database um, and I want to retrieve that. Okay, and I'm going to let it generate my program. So it'll generate a script that'll say, hey, here's how you can collect data from a MongoDB database. And I can look at this and say, okay, let's go ahead and change this. I actually want this to be a Spark program, not a Python program. So write me a Spark program that will get data from MongoDB. And I'm going to copy and paste the rest of this because I don't want to retype that. So we don't want to use the Mongo client. We actually just want to use Spark for doing this because it has much better capabilities. So it's hey, here you go. Here is a Spark program. Perfect. Oh, it's almost perfect. There's one other thing I want to go ahead and tell it to do and say, I already have a Spark object initialized. So do not initialize Spark. Set my options for collection, URI, and database in the Spark recall. And we should have our little program written completely in AI, assisting me in less than what, 2, 3 minutes. The only thing I'm missing is the actual URI itself, which I have copy and pasted off screen. So that's not AI dependent. That's actually dependent on my database platform. So we're going to go ahead, set that variable, and real quick, you can ignore it. We have a generic demo platform for doing this. So I can actually run this now that we've used the do this and say, okay, perfect. We have output coming from a live MongoDB database, but I don't like the printout. I don't like the printout. Can I get this in an interactive table? And that should have been a question, not a period, but that's okay. But it will go ahead and rewrite this and say, yeah, sure, we can get this in an interactive table if you'd like. Let's go ahead, and it changes our print to a display. And sure enough, when I go to rerun this, we no longer have this inside of an interactive table, or inside of a printout. It's now inside of an interactive table. So I was able to use our generative AI capabilities inside of the data intelligence platform to create a script to retrieve data from MongoDB in less than 5 minutes. So that's pretty impressive. So now let's take this one step further and say, what happens if I'm from, one of the other organizations, let's say HR or marketing or something like that, and I don't want to come into notebooks to get these insights from my data. Well, that is where we can come into our Genie data room, and I'm going to look for my classic models data room. And I can come in here and say, okay, I can now interact with my data using natural language to get insights to this. So we have a couple of, default options here. Hey, what are some example questions that might be able to be asked from this data? Explain this data set to me. So if I wanted to know each of the tables, how they relate to each other, it will give me a full description of that. Or we could say, hey, surprise me with a question. Just think of any random question that could be asked, and we'll click on that just for fun. But let's say I want to know something like, give me the top 5 sales reps based on order history. Um, So we will go ahead and let the random question finish thinking real quick before we ask the next question. So the random question with this query will count the number of customers in each country. It groups customers by their country, then orders the results in descending order. So we could have asked that in a natural language and gotten the results. But in this case, I'm saying, give me the top 5 sales reps based on order history. So it's going to think and it's going to process this data and give me a result. So just while we're waiting for that to process, I can come over and look at the generated code from our previous question and see that it generated a full SQL statement for me. It did, in case there weren't any joins in this case, but it did all the grouping and aggregations for me. Here is my top 5 salespeople. So I now know who the top 5 salespeople in my organization are. If I look at the generated code for that, I can see it also took care of all of my joins. Because it knew the lineage and what this data was being used for, it knew how to join all that data together and give me the insight I was looking for. So if I want to, I can say, hey, let me visualize this. Let me create a bar chart of each one of these users. So keep in mind, I'm not writing any code here at all to get this. I'm just interacting with the data using natural language, just as if I was having a conversation. So we'll let it think, we'll let it run, we'll let it generate the bar chart. But while it's doing that, I can go look at this other, chat history that I had and the questions that I've asked of it previously. So top 10 customers who have placed the most orders, top 5 sales reps, give me the top 3 offices based on sum of order details. And then the visualization, what it looks like when I create the chart. So again, utilizing just natural language to generate and interact with this data. So with that, I'm going to go ahead and let's take this demo down to a close. I'm going to stop and ask, are there any questions before we close out? Okay. Well, I'd like to thank everybody for their time. Thank you so much. If you have any questions, please feel free to reach out. We're more than happy to answer. We'd love to help you be able to democratize your data and AI. Thank you. So, all right, we can